Okay, ready? All right, guys, we're gonna try our homework today like this. So obviously, just like always, follow along, change your answers, think through my questions, and if you haven't done your homework, you need to be sitting on the carpet without your homework, okay? All right, here we go. The first problem that we have is to estimate the sum. So that was 64 and 563 thousandths plus 81 hundredths. So what should we estimate 64 and 563 thousandths to be? What would be close to that we could solve in our head? I'm thinking maybe about 65, right? Because 64 and then 5/10, so it's kind of in between 64 and 65. 64 would also be okay. And then what about for 81 hundredths? Think here about money. If this was 81 cents, you'd have about how much? You'd have about $1, right? And either of these you should be able to solve in your head. 65 plus 1 is 66, 64 plus 1 is 65. So I would guess that our answer is going to be between 65 and 66, somewhere between there. And our next problem is to actually solve it, so let's go ahead and do that now. So 64 and 563 thousandths plus 81 hundredths, making sure we line up those decimals. Can annex a 0 here. Got 3, 7, 8 and 5 would be 13, 4 and 1 would be 5, 6, our decimal goes in one straight line. So how would we say this decimal? Go ahead and say it in your head. Right, so 65 and 373 thousandths. Okay, next we need to estimate the estimate the product. So what is a product? Think in your head, what is a product? Product would be the answer to a multiplication problem. So we want to make sure that these numbers have enough zeros that we can solve them in our head. So what would you say is close to 42 and 5/10? Something we could solve in our head. I'd say 40. And then what about 71 and 9/10? I'd say 70. Can we solve 40 times 70 in our head? Should be able to. If we cross off those zeros, we think 4 times 7. What is 4 times 7? And then we add our 2 zeros back. Now here's where kids mess up. Remember, sometimes kids will want to put the decimals in their estimate, but we don't have any decimals in our estimate at all, right? We've changed these numbers so that now they don't have decimals so that they'll be easy to solve in our head. So even though our original problem has decimals, our estimating problem doesn't. So that means our answer also doesn't need a decimal. So your estimate is going to be about 2,800. Okay, so now let's solve it for real. So I'm going to draw my lattice boxes. I need a 3 by 3. Go ahead and flip your paper, check your work with me here. 4, 2, 5, and 7, 1, 9. 5 times 7 would be 35. 2 times 7, 14. 7 times 4, 28. 5 times 1, 2 times 1, 4 times 1. 5 times 9, 9 times 2, and 9 times 4. Now we add diagonally. Let's see, I might do 9 plus 8, which would be 17. Carry my 1. 6, 7, 8, 9, 10. 10 and 5 would be 15. Carry my 1. 4, 8, 12, 13, 14, 15. Carry my 1. 8, 9, 10. So I get 3, 0, 5, 5, 7, 5. And then let's see, in our original problem, we had a decimal here and here, so we moved it 2 spots out of the way. So we need to move it a total of 2 spots back. So we get 3,055 and 75 hundredths. And our estimate was 2,800. Is that close to our estimate? It's pretty close, not bad, right? We're in the same place value. Thousands, we're only a couple of hundred away, so I'd say we did it well. Okay, next we're going to find 100th less and 100th. All right, let's do the fractions first and then we'll do the decimals. So the first fraction set we have is 1/5, and we're comparing it to 2/6. So looking at these, we don't have the same numerator, we don't have the same denominator. They don't look like they're super different. One's not really big and one's not really small. So I think this one we need to make equivalent fractions for both with the same denominator. So what should we use for 5 and 6? Something we can turn into 5 or turn 5 into and turn 6 into. If you're not sure, you should list multiples of both. I could list multiples of 5, but I know about multiples of 5, right? What do we know is true about multiples of 5? They all end in 5 or 0. So instead of listing out my multiples of 5, I'm just going to list the multiples of 6 and sit and think which multiple of 6 is the smallest one that ends in a 5 or 0. So 6, 12, 18, 24, 30. There we go. 30 would be the one. So let's make this one into 30ths and this one into 30ths. So we think 6 times 5. Do the same to the top because that's what makes it equivalent. And then 5 times 6, do the same to the top. So we've got 6 30ths versus 10 30ths. So 6 30ths would be less than 10 30ths. Okay, the next one is 1/4 and 2/3. So this one you may be able to kind of draw a picture and think which is bigger, right? If you guessed on this one because you thought you could picture it, I can support that, right? So this obviously looks smaller. Let's do a quick math check and just double check. I'm going to use 12 as my new denominator for both of these. And just make sure 3 times 4 is 12, so 2 times 4 is 8. 4 times 3 is 12, and 1 times 3 is 3. So yeah, obviously 3/12 is smaller than 8/12, but it's always good to double check, so we should be good there. And then the last one we have is 2/8 and 4/16. So this one follows our rule where we can make one of the denominators into the other, right? I can make 8 into 16, so I'm going to do that. So 8 times 2, and so 2 times 2. And what does that tell us about these fractions? They are equivalent. Okay, let's look at those decimals now. We've got 3/100ths and 3/10ths. So remember, it's hard to compare decimals that don't have the same place value. So to make them have the same place value, I'm going to annex a 0 here. So now I have 30/100ths and 3/100ths. You can also think of these as money. So 3/100ths would be greater than, less than, or equal to 30/100ths. Should be less than. And next we've got 5/10ths and 8/100ths. Again, hundredths and tenths, so we'll need to annex a 0 here. Now we've got 50/100ths and 8/100ths, 50 cents, 8 cents. So 50/100ths is greater than 8/100ths. And then 63/100ths and 92/100ths. Those are both hundredths numbers, so all you have to do is think of them as money. 63 cents would be less than 92 cents. So far, so good. Okay. Let's keep on going. We've got our rule table here, our X and our Y, which is our in and our out. We've got 3, 4 over here, 21 here, and 36 here. So our rule is divide by 3 and then add 1. So let's see what happens when we apply our rule. So our X is 3, so we're going to start with 3. So 3 divided by 3 would be 1, plus 1 more would be 2. So our number is smaller over here. But we have 2 operations, so it doesn't follow our normal rules. Let's come back to this one, do this one last. Let's do the 21 next. So 21 divided by 3 would be 7, and then plus 1 more would be 8. 36 divided by 3 would be 12, and then 12 plus 1 more would be 13. So this one is the trickiest because we got to apply our rule backwards. So I'm going to start with the back of my rule. So instead of 4 plus 1, I'm going to do 4 minus 1, right? Which would be 3. And then instead of divide by 3, I need to do the opposite, which would be times 3. So that means 9 goes here. Seems a little confusing, so let's double check by trying it with 9 and seeing if our rule works there. So 9 divided by 3 would be 3. 3 plus 1 would be 4. So does that work? Great. One more section here. We've got simplifying to lowest terms. We've got 11 over 33. So when we're simplifying, we're dividing the top and the bottom by the same number. So if you're not sure what to divide by, you can list the factors of the numerator. Factors of 11 would be 1 and 11. We know we can't divide by 1 because nothing happens to our fraction when we do that. So the only thing we can divide by is 11. So is 11 times something 33? Yes, so let's divide by 11. 11 divided by 11 would be 1. 33 divided by 11, or blank times 11 is 33, would be 3. And then finally, 6/9. If you're not sure what to go into 6 and 9, you can list factors of 6. 1, 2, 3, and 6, and then say is 6 times something 9? Nope. Is 3 times something 9? Yes. So let's divide by 3. So 6 divided by 3 would be 2. 9 divided by 3 would be 3. And that is what you would get. Okay? All right, I'll see you guys on Monday. Do your best. Make good choices. Bye.